And we are back. What is up, everybody? My name is Nick. This is Swiftful Thinking. We are in the Swift Concurrency playlist. This whole playlist is dedicated to async and await and asynchronous programming with the new Swift Concurrency syntax. One thing I have not yet covered is async streams. I probably should have covered this earlier, but I just didn't really know about it when I first made this playlist. So earlier in the playlist, we took a look at checked continuations. And if you were with me, that was a way to take our escaping closures and turn them into async await. So we could take any sort of asynchronous code and convert it into an async await function. Now that was really helpful, but if you remember, there was one limitation of those continuations, and it's that the continuations must continue one time exactly. So what happens in our app if we have some sort of closure that's going to execute multiple times, more than just once? What happens if we have some sort of publisher or a listener and we want to receive this data a bunch of times back in our application, not just once? Well, the way we do that in Swift Concurrency is to use an async stream. So a couple of videos back, I covered async publishers. That is basically a version of an async stream that came by default with the app published that we've been using. This async stream is basically creating one of those streams by ourselves. So we're going to create custom asynchronous streams in this video, and we're going to learn how to convert the old school escaping closures into asynchronous streams. This is incredibly important. So if you use like Firebase and you want to add listeners, you want to convert that into Swift Concurrency, this is how you would do it. Anytime you have those completion handlers that are executing multiple times, you can convert them now into Swift Concurrency with an async stream. But before we begin, do not forget to hit that subscribe button, leave a like, leave a comment, join our Discord if you really want to get into the community. This is free educational content. Hit that subscribe button because why not? Let's jump into Xcode and write some code. And we are back in the Swift Concurrency Bootcamp. I am super excited to be working in this playlist because async await Swift Concurrency is the future of iOS, and it is here. I've been using Swift Concurrency since I've made this playlist, and it is awesome. It just keeps getting better. One thing I did not use when I first made this playlist was async streams, partly because I had just never used it. I was never really exposed to it. But recently, I've been using it in every single project, and I think you will too. So we're going to dive into what an async stream is in this playlist. If you followed this playlist already and looked at async publisher, that is basically an async stream. If you followed my other playlists on Combine and we set up publishers and subscribers, async streams are basically the same way. Instead of actually calling it a publisher, now we call it a stream. And basically, instead of subscribing to a publisher, we're just going to listen to the stream. But this will basically be our final replacement, if you will, for Combine. So going forward, there's almost no need to really use Combine because we can do it all with async streams, which is awesome. Let's dive into it. Let's right-click the navigator and create a new file. Let's make a Swift UI view and we'll call it Async Stream Bootcamp. Let's click Create. Let's get the preview working here. I'll hide the navigator and make this a little bit bigger for you guys. And we're going to do actually some setup here. We're going to do like an MVVM setup. We don't need to use MVVM, but I think it helps just to make the code a little cleaner for the educational purposes. And I know iOS 17 has come out, so I can use the new observed macro, but I haven't covered it yet, so we're not going to use that just yet. I will cover that in an upcoming video. So we're still going to use the observable object that we've been using all along. Let's create an app main actor, final class, and I'll call it async stream view model, conform to observable object, open the brackets, create an app published, private set. Let's call this current number of type integer, set it equal to 0 to start. We're then going to create another class, and let's just call this async stream data manager. It could be any manager class in our entire application. And in here, we're going to create a simple function called get fake data. Open close parentheses and open the brackets. Before we move forward, let's just connect this to our view here. So I'm going to take my view model. Let's make this an @state object private var. Let's call it view model. Set it equal to a new AsyncThrowingStream view model. We're going to put this number on the screen. So let's call viewModel.currentNumber, and let's put that inside a string so that we can actually see it on the screen. Number 0 is right there. Let's create a reference to the manager. We'll say let manager, and we'll set that equal to a AsyncStream data manager. And then let's just create a function inside the view model called onViewAppear. And when the view appears, we're going to run some code. The first thing we're going to do is have this return us an integer just to make sure it's working. Let's return some random number, and we're going to call manager.getFakeData. We'll set that equal to the current number. Cool. Let's do onAppear, and we're going to call viewModel.onViewAppear, and the number's on the screen. Easy enough. All right, now we're going to simulate getting a stream of data. So if you followed my advanced learning bootcamp, we already did something like this. So I'm going to basically take some of the code from that video. I would also highly recommend, it's still pretty relevant. In the advanced learning playlist, there's a advanced Combine publishers and subscribers in SwiftUI. And it's basically just some really advanced publishers and subscribers using Combine. And the reason I'm referencing this is because basically everything that we did in using Combine in this video, we basically are going to now start to be able to do using async await, but using streams instead of subscribers. So it's the same thing basically as publishers and subscribers, except for Swift concurrency. Now, as I make this video today, there's still some things that are in the Combine framework that are not yet released in Swift concurrency. I'll talk about that later on. But generally speaking, for most things, we can now migrate over. So definitely check out this video if you haven't. But anyway, we're going to jump back in here. We're going to create a function to get some fake data. And to get some fake data, we're going to use a completion handler because we want to return a bunch of pieces of data, a bunch of numbers back to our view model over time. So it's not returning a single integer, but it's returning a bunch of pieces of data over time, because that's what we're simulating here. We're simulating a stream of data coming into our app. We're subscribing to a publisher that would publish data over time into our app. So what we're going to do here is create, let's say, let items of type array of integer, and I'm just going to set it equal to an array of like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Again, this is just fake data. Don't get confused by this stuff. And we'll loop on these items. We'll say for item in items, and we're going to do a simple dispatch queue, the old school delay, a dispatch queue .main async after now plus, we're going to say the item, and then we're going to execute this block of code here. I'm going to hold the shift button and open the brackets and then press enter. All right. All right. Looks like this should actually be a double of item. So what is this code doing? This is basically we're looping on this array. And then for each item in the loop, we're going to say delay now plus 1 second, plus 2 seconds, plus 3 seconds, plus 4 seconds. And then this block will execute after each of those. And when this block executes, let's just return that item back to our view down here. And so to do that, we're adding a completion handler here. We're going to call a completion, and this will be a function that returns nothing, also known as void. But the function is going to accept an integer. So we're going to use an underscore here, and we'll say value of type integer. And we'll call this completion from in here. We'll just pass in that item back. So 1, 2, 3, 4, 5. And then lastly here, let's remember that this closure, so these closures, this execute time could be 10 seconds after this closure finishes, right? So let's remember that this closure here is synchronous, and then this is asynchronous. So this closure will execute immediately, but this closure will not execute for 1 second, 2 seconds, 3 seconds, 4 seconds. And so since this closure calls the completion, and this completion therefore needs to live longer than this closure lives for, we actually need to make this escaping. So we now have our escaping closure here, and we're going to call this from our view. So let's rewrite this as manager.getFakeData. Click enter on the completion. Make this a weak self for a weak reference. If you don't know what weak self is, check out my continued learning playlist. I have covered it in great detail. We're going to call self.completion. current number equals the value that is returned. If we did this all right, we can see that over time, every second, we're going to get a new value onto the screen. Super cool. So the reason we're doing this is because in most cases, when we have some sort of stream, it's probably coming from some API that basically has some sort of closure, some completion handler in it. And this is how our code generally looks. And in other videos, I've showed you how to convert this to a Combine publisher, but now we're going to convert this to an async stream. So before we do, I want to just jump back to, if you're following this playlist, there was a video a while back called Check Continuation Bootcamp. And in the checked continuation bootcamp, we took a completion handler and we converted it into an asynchronous function that throws data. So this is essentially the exact same thing as that. We're taking a completion handler and we're converting it into a asynchronous function. The only difference is the continuations return one time. I stressed in the video, it's even in the documentation, that these continuations return one value one time. So it's an asynchronous function that throws and returns one piece of data one time. This is if that return needs to happen more than one time. So it's going to be an asynchronous function that returns a stream of data. So a bunch of values will return over time. So if you have a completion handler that's only executing once, use a checked continuation. If you have a completion handler that's going to execute multiple times, we're going to use an async stream. So in this case, this closure here, this completion is going to execute basically 10 times. So how we're going to do this, we're going to write another function here called get, let's call it get async stream, open close parentheses and open the brackets. And the function, of course, will return an async stream. Cool. Now, when I type this, we're going to get an error here. Reference to generic type async stream requires an argument. So an async stream, just like a Combine publisher, can publish any type of data back. A stream, we can stream any type of data. So the stream is made to be generic for any type of data. But we need to put in here what type of data is going to be returning. And we know this is going to be, we're going to stream integers. So this will be an async stream that returns an integer. And we're literally going to call async stream. And there are two completions here. We're going to use this first one with an element type buffering policy. I will hold the option button and click enter. So element type, what type do we want to return from this string? Obviously, it's going to be an integer. So we'll use int.self referring to the type of integer. The buffering policy, I am not going to worry about. I'm actually still trying to figure out exactly how it works. There's some documentation on it, but it seems confusing and I've never had to use it. So sorry guys, but we're going to just leave that out. If I haven't had to use it, I assume most people following will also not have to use this for a while. And then we're going to click enter here. And in here, we're going to get a continuation back. So we'll call it continuation. And now all we need to do is get our completion handler and then call the continuation every time the completion handler triggers. So we'll call self.getVacantData, press enter on the closure there. And then we're just going to call continuation.yield. There's two calls here. It's yield or finish. We're going to yield, meaning send a value through our stream. So we're going to yield the value back to the application. It's that simple. All we did, basically just wrap your completion handler inside a stream. And now we have a stream that we can return back to our application. So let's go back down to our code here. And instead of calling this completion handler, let's just call manager. Let's create a task. And we're going to say for await value in, let's call manager.getAsyncStream. So this is going to return us back to stream. And let's open the brackets. And now we're going to get the value back. And we'll set current number equal to the value that is returned. All right, I'll zoom out a little bit here, guys. And if you rerun your preview, you'll see that it is now still working. And I think this is so incredibly easy to use and awesome because now we can just use async await code basically everywhere. And we don't have to deal with these escaping completion handlers directly. So if you have these closures, so for example, in Firebase, we have the listeners. I did a whole video on Firebase listeners. those have completion handlers. But now we can write a quick extension or alternate function to basically convert any completion handler into an async stream with just a couple lines of code. This is awesome. Before we wrap up, let's talk a little bit about this. So firstly, right here, we do have a strong reference to self. So we probably should make this a weak self if we can. Secondly, the Swift compiler is so smart. And because we are returning a integer, it can actually infer that this is going to be an integer. So we can actually just leave this off and it will automatically understand either from here or from here that it's going to be an integer. So our code looks even better, even less code that we have to write. And when we were calling this continuation, we also had the ability to call finish. So finish the stream. So the question would be, when might we want to do this? Well, with this current setup, we don't really know when the completion handler is finishing, but sometimes an API will have some sort of finish method, or you might trigger it yourself. So let's actually add to this function here another closure. We're going to say on finish, which will be an escaping function that is a function and returns nothing. And we're just going to call on finish from inside here. We'll say if item is equal to items.last, we'll just call on finish. All right, so when I call self.getFakeData, I will have my completion, which we probably shouldn't call completion at this point because it's confusing with on finish. So let's just call this maybe new value. So we'll call get data, the new value, and we'll call continuation dot yield the value. And then on finish, so when this actually ends, we will call continuation dot finish. Let's update this to new value, and this should work. All right. We also don't have any errors coming through this get fake data. Well, we should probably simulate that because there's definitely situations where we might actually throw errors from our get data function. So let's actually add, maybe inside this closure here, we'll add an error of type error and we'll make it optional. So we'll just call nil inside the closure for now. But inside this closure, we will get back the optional error, and that will be inside this closure. And we can just say if let error. So if there is an error, we would actually want to call continuation dot finish, but we want to finish and send back an error back to our app. And right now you'll see there is no error completion here. And that's because this async stream is not throwing. So remember, if you followed this playlist, we had checked continuations and then checked throwing continuations. And the only difference was whether or not it was going to throw an error or not. Well, now you probably guessed it. We have async stream and async throwing stream. And the only difference is that throwing one can actually throw an error. All right. An async throwing stream actually has two generic types. It is the value as well as the error. So we'll also give it an error that we're returning. And then if we get the error, we'll call continuation.finish, but we'll actually throw the error. And we'll say else continuation.finish without throwing the error. And if we actually look at the closure there, I think it's actually optional, the error anyway. So we could just pass in the optional directly. We don't even need to check for it. Probably make our code a little bit better. Awesome. When we come back to our code now, this async stream can throw an error. So we probably want to put this in a do catch block. So here I can print out the error. If the error is coming back, I can handle it in my code, but we got to add our try. So we're going to try, await for a new value. If the error occurs, we will execute this block. Cool. A couple final things before we wrap up here. Firstly, I want to point out that the life of this task is different from the life of this closure. Okay. So we need to manage these tasks at the view or view model level. So really quickly, inside this dispatch queue, I'm just going to add a print statement that says new data, and I'll just print out the item, the integer. And then I'm going to take my async stream bootcamp and make that the first view in this app, and I'll run it to a simulator just because I want to get those printouts coming out to the console. Let's jump back into our bootcamp. And I can see here, once this starts running, new data 4, 5, 6, 7, 8, 9. And the reason I'm showing you guys this is because if we cancel this task, it is not going to cancel the code inside here. And I think that's important for developers to know. So I already showed you guys how to cancel tasks. So I'm just going to do a quick version of it. We'll say let task equals this. And let's just call a dispatch queue here, dispatch queue.main.async after maybe now plus 5 seconds. And let's just call task.cancel. All right, so we will set up this stream and we're going to listen to the stream, but then we're going to cancel this task. So this entire task after about 5 seconds. Now I'm just trying to highlight that canceling this task will cancel this block of code here. So we're not updating our UI and our view model, but it's not going to cancel the actual code inside that completion handler. So let's put a quick print statement in here, task canceled. Let's run this to the simulator real quick. And we should see new data, new data, new data. The UI is updating still, canceled. Now new data is continually coming through here, but the UI is not getting updated. So we canceled the task in our view model, but we didn't cancel the underlying function. You would have to manage this separately, probably in the code itself. So generally, I think most of the time that you either don't need to cancel it or it would be handled for you, depending on the networking logic that you have. You probably want to make sure you don't have any strong references in here or in here. But just know that canceling the task is not going to cancel that underlying function. Last but not least, inside this stream, we can actually start to use some of those cool Combine methods that I looked at. If you followed me in the advanced Combine publishers and subscribers, which I highly recommend still watching this, because basically all of the code that we did in this video is going to become relevant inside these streams. The only difference would be instead of subscribing to a publisher, we're going to listen for a stream now. But so on this stream, we can now call things like drop first. So I will drop the first, maybe the first 2 publishes or the first 2 streams inside this stream. So for example, if I run this now, let's run to the simulator, you're going to see that the new data is coming through, but the first item that came through was number 3 because it dropped the first 2 publishes. I'll do that one more time. It's 0, 1, 2, and then third, it published through. So we dropped the first 2. And the final thing I'll point out here is that some of those methods that we used in Combine are not yet available out of the box for async streams. So for example, debounce is a very common one, but there is no debounce in the framework just yet. So firstly, if you want to learn all the different methods that you can do for publishing values over time, things like drop first or throttling or debouncing, I highly, highly recommend watching this Advanced Combine Publishers and Subscribers. This is a 2-hour long video where I went through all of those methods. It's basically the same thing that we just did in this video, except instead of using streams, we're using publishers and subscribers, but the actual logic for listening to data over time is the same. So I'm not going to do an entire massive video, a 2-hour long video, just to update this one line of code. So I highly recommend if you haven't seen that video, check this out. It is so incredibly relevant. But the last thing I will say is that although debounce is not available right now, it is on its way. Because if we go and Google async algorithms, the Swift team did release an async algorithms package, although right now you have to import it separately. So it's not coming out of the box inside a version of Swift just yet. So you can go to GitHub, you can click on the GitHub link here, and then you can import the Swift package into your code base, and you'll see a lot of the methods that we covered in that other video. So in this Combine Publishers and Subscribers video, I looked at things like debouncing and throttling and zipping and filtering and mapping. So all of these cool things are coming, but they're not included in the language just yet. So I will definitely do a video in the future where I go through as much of this as I can. There's some new things in here that I'm not super familiar with, but like I would love to have removed duplicates. I would love to have debouncing is probably the most important in my mind. But I think there's probably a reason that this is not in the Swift language just yet. I don't really know what that reason is, but I think eventually, maybe they're still, changing some of the APIs, but I think eventually it will be included in the Swift language. Just like when we import Combine, we get all those out of the box. Maybe we'll have an easy import async algorithms and we'll get all these out of the box. So I'm going to try to hold off on a video covering all of that until it actually is included in the Swift language. But in a couple months, if it is not included, maybe I'll just actually import this package. Regardless, you can learn all of these methods, how to use them at least inside this Combine video if you're interested. All right, wrapping up here, async streams are basically the same thing as checked continuations, except they return multiple pieces of data over time. They are what we would have called a publisher and a subscriber in Combine. We now have a stream and we listen to the stream in Swift Concurrency. Super powerful, super useful. And this basically gets us all the way to using async await for everything in our code. And I think we almost never have to deal with closures anymore, which is awesome. Let me know what you guys think in the comments below. And thank you all for watching. As always, my name is Nick. This is Swiftful Thinking, and I'll see you in the next video.